Um, please, I want you all to welcome her. Sarah, please, you have the floor.
Okay, thank you. Good evening, everybody. So I'm trying to share my screen now. Come in. Okay, I can't share my screen for some reason. Host disabled attending sharing screen. Please, can you fix that?
Can you try again? Sorry, I just fixed it.
Okay, okay, thank you.
It's working now, right?
Yes, it is. So please help me confirm if you can see my screen.
Yeah, we can see your screen.
Okay, thank you. So, good evening, everybody. Once again, my name is Oluwatosin Sarah, and I'll be taking you on, review and practice. So, the agenda for today's will be so basically, I was supposed to just like walk you through a crowdfund contract, but then that crowdfund contract that we're going to be building will be created from a factory contract. So I would like to like introduce you to what we know, what factory contracts are, and then create a ways to create smart contract from a factory contract, and then write a simple contract first, deploy and interact with it before we now like go into the crowdfund contract itself. So please, I'd like you to try to concentrate, and then if you have any question whatsoever, please don't hesitate to ask. So yeah, this evening, I'm a blockchain developer and also a content technical writer. So what are factory contracts? So factory contract is a smart contract that is designed to create and manage other contracts. It is also sometimes referred to as a contract factory or a contract generator. So basically, what a factory contract means is that um, it is a contract that deploys other contracts based on a particular template. So let's say, for instance, now I want to use an example like a a factory that produces cars, right? So this factory that produces cars, they have a set of predefined templates that each car type that they want to produce have, right? They have all the specifications that that particular car that they will be produced from that factory has. And then, so a factory contract is just similar to that, right? So a factory contract, for you to be able to deploy a smart contract from a factory contract, it has to have a template, a already defined template. So then you create and generate a lot of duplicates of that template from that factory. So it is that factory that is now responsible for deploying other uh, other duplicates of that particular template. So a factory contract typically has a function that allows
I think Sarah is rogging, or am I the only person?
contract. So the factory contract is okay this instance with the appropriate parameter contract called my token that represents a factory contract that has a of my token contract. So it's a contract, my token. So you can use or see that in practice, or just to like make you have an overview of it. So when a user calls the create token function on the factory contract, the factory contract will deploy a new instance of my token contract. Yeah, my token contract is the template. So now it's the factory that will be deploying duplicates of that template. That's just how factory contract works. And set any initial parameters such as token name, just like ERC20, token name, symbol, and all other parameters you want to initialize as specified by the deployer. So the use of factory contract can simplify the deployment and management of smart contracts, particularly in cases where many contracts need to be created. It allows for greater flexibility in managing the life cycle of this contract. So the basic use of factory contracts, right? Instead of having, let's say you want to you're working on a production of you're given a gig to work on a contract for different, let's say different companies, and those different companies, like, is the same functions or the same templates that they want for all those different companies. So instead of you trying to like, okay, you code this one, you deploy, you're deploying one by one, a factory contract will handle that for you. So that's like the basic. And then the factory contract, it will manage all the addresses of the contract that's been deployed or created from it. So that's the use of factory contract. So ways to create a smart contract from a factory contract. First way that you can create a smart contract from a factory is using the new keyword. Using the new keyword. So one common way to create a new smart contract instance from a factory is to use the new keyword. This involves defining a contract template and then instantiating it using new when needed. So for instance, now I have contract, my contract here, and then all other functionality that you want to have here will be here, contract code. Then I have my contract factory. So in my contract factory, I have a function that creates contracts. So you can see public returns, it returns address. So this address that it returns will be address of the newly created smart contract. So you can see that from here you have address, just typecasted it so that it can return the address of this newly created my contract. You can see when you want to use the new keyword, you use new, then the name of this, sorry, the name of this contract, my contract, oh, sorry, the name of this contract, and then you call it. That's just a simple way of creating an instance of a smart contract, and already defined template or smart contract using the new keyword. So another one is using the create function. So another way to create a smart contract instance from a factory is to use the create function. This function is available in Solidity version prior to 0.8, and it creates a new contract instance using the contract bytecode. So before I go into this, I want us to look into creation code, init code, and runtime code. So creation code is also known as the bytecode of your smart contracts. First thing, we know that Solidity is a high-level language, and then the EVM doesn't understand the function or the English that you are writing. It doesn't understand that. So before a contract is being deployed to the blockchain, it will first be compiled down to the bytecode. So it's now from the bytecode that the EVM will now like execute your smart contract from it. So like I said, creation code is also known as the bytecode, is the compiled form of a smart contract. It is the code that is executed by the EVM when a new smart contract is deployed to the blockchain. So when you write a smart contract in Solidity, it is compiled into bytecode before it can be deployed. Like I said, the bytecode is a sequence of machine-readable instruction that tells the EVM how to create the contract. The creation code includes all of your state variables, your contracts, constructor function, and all of that. That's your creation code. So your init code is a piece of code that is executed after the creation, when a contract is deployed. Now, in a case whereby you write a contract and it has a constructor, the first thing that runs um, before your contract is being deployed, you need to like set your state for that particular constructor that you already defined. Now, it is that init code. The code that is gotten from there is what we know as init code. So the init code is optional. Like there are some smart contract that doesn't need constructor function in it. So those ones doesn't have the init code, but this does if your contract has a function that initializes the state of your variable, the state of your smart contract. Yeah, it has the init code. So the init code is optional and is used to perform additional contract setup tasks. Its purpose is to initialize the contract state and set its initial values. So that is your init code. So now we have runtime code. Runtime code is executed every time the contract is called or invoked. So you're trying to interact with your smart contract. The code that is generated from it is what we call runtime code. So this code defines the logic of the contract, including how it interacts with other contracts, how it stores and retrieves data, and how it handles transaction. In other words, the creation code is the code. Okay, now the creation code, like I said, which is the bytecode, which is the contract bytecode, is the code that creates the contract. Is the code that creates the contract, while the init code is the code that initializes the contract. It's just the function of the init code is to initialize the contract, while creation code is what creates the contract, and then the runtime code is what executes when a smart contract is interacted with. So that's just the difference between the three: creation code, which is bytecode, init, and runtime code. So now let's go back to the second way to create a factory contract. So a second way, I said using creates. So using creates, you need to get the bytecode of that particular template, of that particular smart contract that you want to create, you want to make a duplicate from. So now we have, this is the template. This is the template that we want to make a duplicate of. So this is my factory, my contract factory, and here is the function that we would be deploying this duplicate. I mean this template, this smart contract template. So in this function now we have byte memory bytecode. So we want to get the bytecode of this particular contract. So the way you get the bytecode of this particular contract is you write the type of the contract is my contract, the name of this contract, dot creation code. Using this only, you get the bytecode of this particular contract. And that is what create use to create a new instance of this my contract. It uses the contract bytecode to create a new instance of a particular contract in a new address. So you define the contract address, because we want to like get the address of the newly created smart contract. So, and then you use inline assembly to run this, and then return contract address. So the third way to create a factory contract, to create a smart contract from a factory, is using create two. So now I said using the new keyword, the first one using the new, the second using create, the third is create two function. Now for create two, you have to pass in a sort. So create two function allows for deterministic contract creation. This means that the address of the new contract can be calculated in advance. So you, wow, please, am I on this call? Please, can you hear me?
Yes, I can hear you, and I can see your screen.
Yes.
Thank you. Okay, so for this, for create two, you have to pass in the sort to create new instance of the contract you want to create. So now this is how you do it. In your factory contract, the function that creates the contract, you either pass in the sort in the as a parameter, or you can define it in your contract, in your function block, whichever one works. So you do this, get the bytecode, pass in the sort. So now you deploy your contract. So you might want to ask that what's the difference between using create and create two. So both actually cost almost the same gas, but create two can be cheaper than create, in the sense that for create two, you're passing the sort, and sometimes you might want to create a contract at the same address it has already been created. So in that sense, that one doesn't have to like create it again. So what I'm saying in essence is that for this sort that you're passing in, let's say you're passing in one as the sort, it generates the address for you. You can still come back again and pass one, it will still generate the same address for you. So in that case, the gas that is going to use will not be as expensive as the create. So just know that the actual normal way of you deploying instance of a contract is using create. But if you want to use create two, is either maybe you want to deploy that instance of that particular contract at the same address. So that's when you should use create two. So that's just the difference. So yeah, so let's build. So I'll be using that. I don't know if they've taught you on how to use that for, yeah, that's what we'll be using. So first of, we're going to be creating a small so please, if you have any question, please you can just compile them for me. I'm going to answer every question. So we're going to be using that now. Now you have to initialize your that project. You do that. So this, you can get all the commands here. Add art. So to set up a new project, you can come here, set up a new project. So we're going to be following this. Set up a new project. So npm init, npm init dash y. So initialize the npm project. Now install that npm install dash dash save dash dev adapt. So you have to wait for a few minutes. I say a few minutes. So after this, we run add ads. So create an adapt project. Adapt. I'm sorry, I want to close this. So create another project, run npx adapt. So now I want to if you want to create a JavaScript project to use this TypeScript, well, I'll be using TypeScript for this project. So yeah. So please, have you used like Ada to build any project? So I will know whether I have to like explain, go in details in explaining. Somebody should respond, please.
No, I haven't.
Okay, okay, okay. So Ada is just like a remix, right? It's it's an integrated environment, development environment where you write your contract, where you it provides that environment for you. You can compile, test, debug, mention it. You can deploy your contract from that to the mainnet or testnet, anyone. So it's just like Remix, basically. So when you're dealing with a large code base, right, you can't use Remix for that. So should start getting used to um, writing your smart contract with that. So we're going to be creating for contracts. So okay, I'm sorry. So as you can see that when we initialized this adult project, it generated a template, like they just like have a template for you. Everything is actually explained in their docs right here. So you can go through it like after now, everything is explained in detail. So it's just like, okay, this folder will be the folder in which your contracts, you write your smart contracts. This is node modules. You don't need any of this node module. This was generated when you were installing the npm, right? So for script, this script is where you deploy your smart contract, and then you can make write your interaction script here also. You create a new file to write interaction script. We're going to do all of that. So the test is where you write your test script. Is where you write your test, you test your smart contract. So for this particular contract that was generated using Hadat, they tested this, and here it is. So I need to, so no, let me save it. So when you want to compile your contract in Hadat, you use npx Hadat compile. So I want to compile the already created template that they have here. So you can see it's which generates your bytecode, artifacts, and every other. So it is here. In your artifact, you can go through it. You will see your bytecode, your ABI, and all of that in your here. We have your bytecode. You can see the contract bytecode, and then we have the ABI. These are the ABI. So that's that for that. So when you want to test, so this is the script they wrote for testing the lock. Wow, time is going. Testing the lock contract they wrote. So you write basically npx add that test. So just want to quickly run it so you can just see. So you can see 9%. That means all the tests that was written and it passes. So no one is failing. So if any of your tests that you write is failing, that means there's something wrong with the smart contract. So that's that. So let's just like build. Okay, so store. So first, oh, I'm sorry, store. I have to delete this. We don't need it. So we want to like create a simple contract that just store a value and then get the value, and then we create a factory that will be deploying this store contracts. So what we do, right? So we have a string public and value, and then a function that sets value. You want to write to the state, to your state. So we have string, and you have to put the memory location, which is memory, and then the value. So you want to now write to these states. So you come here, value equals to your parameter, and that's called value. As simple as that. So now let's create a factory. Or factory, you have to be very fast so that we can. So we already know all of this, I don't need to explain. So contracts, we have store factory. So before you create the store factory, you have to like create an interface. So iStore. So the basic use of this interface here is for all created smart contracts. When you want to interact with any created smart contract, you have to use the interface and then the contract address to interact with the contract. So that's what we're going to be using interface here for. Store, and then interface defines your contract functionalities. It just defines the contract functionalities. It doesn't include your contract logic. Your contract logic is coded in your smart contract. Interface is just used to define your contract functionality. So as you can see here, we have two functions. And the reason why this is two functions is because I set the feasibility of this value to public, and setting this as public means it's a getter function. So you have two functions here. So we have to put it in the interface function value. You set this as external. So since the value is public, right, is a getter function that automatically gets the value that is assigned to that particular state. So we make it a view function which returns string memory. So this is how you define an interface. You don't use curly bracket, you use semicolon. It just defines your function signature. Exactly, it just defines that. So second one that we have is value. So, and set value takes in what parameter? It takes in value, takes in string, memory, value, external. So yeah, so this is what we need. So you should also keep in mind that when you're defining your contract interface, now this interface is for this template. This store is the template that will get deployed by the factory. So when you're defining your interface, you have to ensure that the function name and everything is the same thing, else you will run into error. And then the parameter is the same thing. I'm not saying the name, the parameter, I mean the data type and all of that is the same thing. So you will not run into error. So now let's write, we need to import this, sorry, this is the store. We need to import this interface. So because this store is using interface. So I'm importing the interface because the this contract, the store is using the functionality of the defined the functionalities we have in the interface. So now let's write the store factory. The first thing that we want to write here, we want to write our events. Sorry, events. So the only event that you need right here is contract created to emit an event that, okay, this particular contract has been created. So, and also you need to import the templates that you want to use by using store. So you need to import it, indexed, new store contracts, new store address. Let me use address. So, and then we want to emit the position of that particular contract. I mean the index of that particular contract that was created. So we use uint. Let's use position. Yeah, contract position. So we have it right. So now we want to now create the function that will be deploying that particular store template. So create store. To create every store, we remember that in this particular, okay, we don't have any constructor function. Okay, so in case you have a constructor function or any function that initializes the state of your variable in your template, you have to put it in, you have to pass it in as a parameter. So I hope you're following. Please, if you're getting confused, just please let me know. So we have, since we're not initializing the state, external, we just want it to return the address. Let me use address here, not store. So yeah. Okay, no, let's, so I want us to use both. So for this one, we're going to be using this instance, that's this new. For the second contract, we're going to be using create. So we have to store, which is the contract, and then we want it to also return store. So that's the contract type, like the address. That's why we're using store, is an address. So we have, now let's store new contracts, new store contracts. Okay, let me use new store address equals to, we now use new, like I said, the new keyword, then you call the name of the template, which is store. So I hope you are following. I need response at this point. Is there any confusion?
None yet.
I am pretty green, but I reckon I'll catch up later after reviewing the video.
Okay, I hope the others are following you. That didn't come. I hope you guys are following.
Yes, we are following.
Okay,
Yeah,
thank
following.
you. Okay, thank you. So now I said this new creates the new instance of the particular store contract. Now we want this store factory to store all the addresses that's been created using, that will be created using this particular factory. So we need to state is we need to like write a state variable that will, an array that stores all addresses, all store addresses. So whenever we are creating this contract, we want to be pushing those addresses into this array so that we can query it later. Okay, all this is all the contract addresses that have been created from this particular factory. So now that we have this, so we just want to push this new address into this array dot push new store. That's that. So we now want to emit the event. It's that simple. Contract created. So this position is the index. So I want to get the index of this particular address. So what we do is we use all this particular states, all store addresses dot length. So it gets the index for that particular for this particular contract that is being created. So let's say, for instance, now the first contract is being created. The length will be 1. When the second one is created, what we get emitted is the contract address and then the position, which is 2. So that's how we get that. So now let's return. Let's now return. We want to return the new store address. So that's that. So now let's create a function that gets all store or all created store addresses. So you can do external view returns. I'm going to return an array for you. So array in memory. Yeah, so you just return this all store addresses. So what if we want to get, we actually need to get the address of this of the newly created contract. So what we do, let's do this. Let's create a mapping that maps the contract index to the address in 256. So once you pass the ID, the contract index, it should create the contract. I mean, you should get the contract address for you. So let's make it public, but we have to interact with it. So that's that. So and we need to define the contract index also using contract index. I want also to initialize it with 1 so we can implement it here. So we need to, before pushing it into this array, we need to underscore. So we have underscore contract address. They are passing in the contract index. So contract index, which what's happening? Passing the contract index equals to the passing the contract index. So now, so right here, the reason why I initialize this with 1 is because the default value of all state variables, basically of all data types, I mean, is 0 for uint, for unsigned integer is 0. So I want it to be like, okay, the first index should be 1. So once the first index, the first contract that will be created by this factory should take that index 1. That's why I initialize it with 1, so that it will not give me 0 or whatsoever. So I have that. So I need to increment it. I need to increment it at this point. After pushing it, I need to increment it so that the other contract that will be created will use this index. So yeah, we have save. We have our factory, our store factory. Right. So now let's deploy this contract. Let's deploy this contract. So we don't need all of these things that they giving us. So we want to deploy. We have const. What's the name of the contract? Store factory. Well, what we'll be deploying is store factory equals to await items dot get contract factory. So the contract factory, we have, you're going to put the name of this contract. Make sure you're not copying the wrong thing. Paste here. And then you want to deploy the contract const store factory equals to await await store factory dot deploy. This is just a simple way of deploying your contract using ADAT. So now what you do right now is you want to console.log the contract address. So store factory contract address is, I really want us to be able to do everything today. Store factory address. So the reason why I'm using .address is because, so if we console.log this store factory, is going to generate a whole lot of things for you. You're going to be seeing transaction hash, you're going to be seeing bytecode and all of that, and we don't need that. What we need exactly is the factory, the store factory address. So I can console.log this for you so you can see. But I don't want us to waste too much time. So let me just deploy this npx ADAT. So we're using this local environment for this. Npx ADAT compile the project first. Compile, okay. Now let's deploy npx ADAT run. To deploy your script, this is the command that you use. Not to worry, everything is in the documentation, so you don't have to like cram anything. Slash, this is the folder, which is the script, this is the file. Now put the file name deploy.txt. So let's run it and let's get the contract address. Now this is the store factory contract address. Now that we have deployed our store factory, we want to now deploy store itself from this store factory. What we simply do is const create store, because just pay attention please. Await items dot okay, I'm so sorry. Await items. So what we want to interact with right now is this store factory. So you come here, await your store factory dot, oh, what am I pressing nonsense? Store factory dot, I think is the name is create store. Okay, yeah. If it's not there, it's going to like draw an error for you automatically. So that's one of the benefits of using TypeScript. If it's JavaScript, you're not going to see any error until you run your code. So we have now create store. So now let's console.log. So we want to await create store dot wait. So what I'm doing here is I want this transaction to get mined before I console.log it. If I don't use .wait, it will not deploy successfully before another function or another interaction runs. So .wait is just used to like wait for this particular transaction, this create store that we're doing, wait for it to get mined before you run the next line of code. So now let's now console.log with we're creating store. We're creating store. Now, since we have created the store, we need to let's check our store factory. We have created the store. Okay. Now we want to get the this address that was created from this store. So we use where's my deploy script? So we can use const first address equals to await store factory dot what is the name of this mapping underscore contract address. So underscore contract address. So we need to pass in the ID, the contract index. So for this, the contract index, we already like stated it to be 1. We want to get that address. So now console.log, you don't need to wait for this one since it's just like a getter function. It is when you're writing to your state that you use .wait. So console.log first store address is now you now console.log this first address. So now let's see, save. Now let's run this. Let's run this. It's giving us first store address is address 0. That means there's something that we are not doing right. There's something that we're not doing right. Okay. Now this is it. This is what we are not doing right. So I'm supposed to equals to what is equals to new store. Now I need to typecast it since. So yeah, save npx. We need to compile it again. Npx add that compile. Let's compile and deploy the contract again. So you should give us the contract address. So now we can see this is the store factory contract address, and then this is the newly created store address that we have. So if you want to create a second address, a second contract, so from that factory, this is just the way that you go through. Like this is just the process. So let's do it again. Const create a second. I'm very bad with naming. A second store equals. So you await. You call the store factory dot create store to create a second. So let me just amend this thing. Create a second store. Wow. A second store contract. Save. Let me calm down. So you await. Like I said, we're writing, we're making an interaction. So we need to wait for this to get mined. We need to wait for this. Now, you want to console.log, you want to get that address. Second address equals to await store factory dot underscore address. Now, now the index that you're going to be passing is now 2. So now console.log second store address is now console.log the second. So I want us to also like get this array that we have here, these all store addresses that we have here. So let's just get it. Const all store addresses equals to await store factory dot, what did we name it? Get all created store. Copy to see. So create. So console log want to get all created addresses, all created store addresses. Yeah, so we have this. Save and let's run the script now. As you can see, we have the first one is your store contract, your store factory, I mean, and then the first store address that the first store address, what am I saying? The first store contract address is this. The second store contract address is this. All created addresses that you've created from the factory is this. You can see this and this. So this is just is as simple as ABC. Now, you now want to interact with one of these addresses that you generated. So what you just, I mean, that you created. So create a new interaction .ts. So and just like I need to copy this. I need to remove all of this. We don't need all this. We're just making interaction. We don't need all of this. So what we need is this. So now what you do right here is, now you want to make interaction. You've already generated your smart contract from your factory. Now you want to interact with that smart contract that was created from the factory. So what you do is const interaction, just naming this as interaction, equals to await meters dot get contract at. Now you call the interface. You can see it is already even giving me suggestions. So the interface is iStore. Now you now pass in the contract address. So let's use, which one should we use? Let's use the second contract address. Copy. Let's use this. So this is just a way for you to interact with your smart contract using an at. You want to interact with smart contracts. You use your interface and then call it with the contract address. Now, let's contract, I say const equals to, if, sorry. The first thing that we want to do is, in this contract, we have value and set value. We want to set the value. Come here, interaction, set value equals to await interaction dot set value. Now you have to pass in the value that you want to set. Anything string that you can pass in. So like I said, your writing to your state, you have to like wait for the transactions to get mined before the next set of code runs. Dot wait. Now let's get value first. Get value equals await interaction dot value. So you're just getting this now. Console dot log my value is get value. So it's that simple. Save. Now let's run this. npx add run script interaction .cs. Okay. Oh, that was a mistake on my end. Interaction, I didn't spell it well. Interaction. So we are having some kind of, okay, is not getting this address that was just, so let me do this. Let's use let's use npx add node. This in address already in use. I'm not using anything. So let's not waste time. Just can just get this, copy this and paste it in your deploy scripts and get everything that you want. It's not getting it in the interaction scripts. That's why it's showing that error. Interaction scripts. So instead of copying this address, so we just use one of these addresses. Either you use this first address or second address. Well, I'm interested with the second address. I want to use second address. So both will give you the same thing. And if I want to make interaction with the second address as well, what I just do is do this, copy this one, name it, give it another name. This one is interacting with the second address. Second contract, I mean, not second address, second contract. So interacting with the first contract, interacting with the first contract. So trace this, give it another name. Let's give it interact second, interact first. So the address that you pass in here now is, just know that your interface is still the same for all contract that is generated from that particular factory. So what did you name that one? First address. So want to set value and get value for the second one also. So set first, get first. Oh, sorry. Because of the time, that's why I'm copying all of this. You have to write that graph font. So is my my first contract interaction. That's what I want to set the value for this for the first contract. That's what I want to set it as. So my first contract value is save and let's run. So note that this one that we are doing, we're just like making use of the um local host. So we're not using testnet or mainnet. But the second contract that we're going to be writing, we're going to be making use of testnet. So you just, this one is just for us to like grasp like, okay, the whole contract stuff, so you can understand it before we like write a complex contract. So here we have it. We have for this one, the first interaction that we did, my value is it get the value anything, and the second one too, my first contract interaction, so it gets it. So do we understand this before we proceed to writing this crowd fund? Do you all understand, or there's any question at this point before we move forward? Any question? Any questions so far? Please, you need to move. Okay. Okay, I hope you get this. We are currently using a TypeScript project. We're currently using a TypeScript project, but you can use any one you like. Is there any question? Do we all understand? No response from anybody? Or can we hear me at all?
Yeah, I can hear you.
So do you understand?
Yes, it's clear from this end.
Okay, thank you. Thank you for your response. Now, so now let's write our crowd fund right now, since we understand this. Now let me create a new folder, Web3. So open folder. So we're going to be creating a new other project again. So if you weren't paying attention, you should do that at this moment. Let me on my lights. Okay, so I said the first thing that we're going to do is npm init -y npm install dev adapt. We're installing the adapt project. So basically, the crowdfund that we want to create, just like we know what crowdfund means. I'm sure a lot of us has like heard about crowdfund, fund me. Like it's like a funding platform for a smart contract that you write. But for this particular one, that okay, you write and people come to donate for a cause. Maybe you want to open that platform for people to donate for different things. On that, you have categories, maybe for laptop for developers, charity, and all of that. But now, the reason why I'm using a factory contract for this, I want us to use a factory contract for this is based on the category that you are going to be having. All these, all the projects that will be created from your platform should hold different smart contracts, should be in different smart contracts. Let's say, for instance, now the first project that you launch on your platform is to donate for laptop for developers. It should be in one smart contract. Maybe the second one too is for charity, for orphans. It should be in another smart contract. So money for it's just to like make your platform organized and like make a whole lot of sense, right? Data for laptop for developers, the state is not clobbering with the state for charity for orphans, like sponsoring orphans, right? So basically, that's the reason that you're using, and it's more security and this in the sense that for each of those smart contracts, for each of those projects that you're creating, the smart contract for each is holding the money, the donated money for each of those smart contracts. So it's as simple as that. NPX adapter, NPX adapts. So using, just enter, 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 enter. So sometimes it can take a whole lot of time before it's finished installing. Let's just hold on. Okay. So now, can someone tell me the first thing that we need to, you think, so I need this class to be interactive at this point, like the things that we need to create this factory, I mean the contract files that we need. Quickly, please. Anybody? Is anybody
Let me
going?
try. Let me try. I think
Okay.
first of all we need the interface. Then
Okay, thank you.
we need the contract itself, and then the last one is the store factory that is used to manage the other contracts.
Okay, okay, thank you. It's not the store factory, I mean the factory contract. Yeah.
Yeah, the
Thank you very
factory
much.
contract. Yeah.
Thank you for that. Thank you very much for that. So now let's create those files. So we don't need this one. Shift delete. We don't need it. So let's create a new file. We have the crowd fund. Crowdfund.so. So let's define 0.8.4. So interface I crowdfund. is good practice to name your interface or your contract with the name that you used to, the name you used to name your file. So we want to have, so now I want us to like begin to give me like suggestions on the functions that should be in our um crowdfund contract. Okay, the first place someone said initialize the contract. Yeah. So I think let's just leave this for now. Let's write the contract itself because we cannot like think of all the interfaces that we want to have right now. So crowd fund factory. So zero point 8.4. So contract crowd fund factory. So yeah, we need to also create the third file, which is the crowd fund, which is the template that we want to use. Crowdfund.so. So 0.8.4 contracts crowd fund. So and then the crowd fund should import the interface, but we have not defined anything in the interface, but it should work based on the interface that we have now. Yeah, so we want to have a crowd fund. We want to write a crowd fund smart contract. Now, okay, thank you. Initialize the function fund function. Okay, we have to have a function to initialize the contract, and then we need a function to fund, like make contributions for a project. Which other function do you think we need? You can just drop them in the chat box. I will check them. So the first thing that we need right here is address of we want to have a crowdfund admin. The admin of this platform, this particular contract. So we need address of the factory. Let's make this public. We need string, which is going to be the title, the project title. The project that you want to create for that particular course. Yeah, the title, say laptop for developers, something like that. Project title. So let's make it public so that people can see. It can be a getter function for people to see. We also need, what do we need? It's not necessary for us to like, okay, state everything from scratch, but then like we need duration. So we can use uint 32 for that. Project duration, like the time. What else do we need? What else do we need? Project targets. The amount that you want people, project targets. Want people to come and donate 100 ether for a particular project. You initialize it with that. What else? So we want to have a Boolean value that checks if the state of the contract is initialized. Initial state of contract. Oh, let me not use initial state. State. Sorry for my naming convention, no. Just so that you can understand. So yeah, as we go on. So the first function that we need right here is, of course, we're going to be needing event. Well, event, and this is our state variables. State variables. So we need our constructor function. Constructor. So in this constructor, we want to set that the deployer of this contract, of this template, of the duplicate of this smart contract should be the factory. So we're going to initialize that the factory, the MLG does send that the contract, or the address that is deploying this particular contract is the factory. So set factory equals to MLG.sender. That's the first thing that we need. So now function to now set up project. Should I use initialize project? No. Create, I don't even know. Set up project. Set up project. So now set up project. The first thing that we want to think, okay, we want to set this project up, right? We should first require that this project, oh my God, this was a mistake. State of contract. How the hell did I use name? So we want to first require that this particular function has not been initialized before. So we want to make a check that, okay, for any one that will now come back again to come and click on this setup project, it should revert, okay, that this particular contract has already been initialized. So we want to set a required statement that we want to require that not initialized for this function to run successfully. So not, let me just name this thing as initialized. Not initialized. So if it's now initialized, it should throw error that contract already initialized. No, the spelling of initialized again. Okay. That's it. That's just the check that we need for this one. So to check that this function has not been initialized before. So now we now want to set up projects. When you want to set up projects, you need to put the project title, the project duration, the target that you need for that project. So string memory underscore title. What else? Uint 256 project target. Uint. What else? 32 duration. And also you want to also set the admin for this particular contract, address of admin. So here are the things that we need to set after we have made this check. Now, the first thing that we set is project title. Taking this parameter title. The second thing is target, project target, which is underscore target. Project duration. Now, for this target that we're setting is going to be in ether, and we know that since we are passing in the ether manually, we need to, and then you know that ether, 1 ether is it has leading 18 zeros at the back, so we need to put times 1E18. So for any amount that you are putting in, let's say you're putting in 1, so it will take it as 1 ether. Because if you just put targets, maybe just put 1, it will be less than 1 way itself. So you need to put 1E18, so it will be recognized as ether. So what else? Project duration equals to, now the duration of that particular project, how long you want that project to last for. You now do block.timestamp, which get the current timestamp plus the duration that you now want to set, underscore duration. So it will only start from that particular timestamp that you set the project plus the imputed duration that you. So this one is going to throw error, and the reason why it's showing error is because normally block.timestamp, the data type, I mean, what it holds is U256, and then I wanted it to be U32, so I need to typecast this as U32. So here we have it. And then we want to set, what else we want to set? Address, admin address. So no, let me not use crowdfund admin, project admin. But for each project, you might want to set different admin for each project. So it depends on you. Project admin equals to underscore admin. But we need to set a check for this, that, okay, this because you're passing in this address manually, we don't want you to pass in an address 0. So let's set a check that require that underscore admin is not equals to address 0. Else show this error that address 0. Be careful. That's that. So now that we have almost all our setup, so the last thing that we need to do, right now is to now set the state that, okay, oh, this particular smart contract has now been initialized. Let's write to the state that, okay, initialized is now equals to true. So that when somebody else comes, what it will throw is that contract already initialized is go away. That's it. So that's our first function. Are we following? Please. Are we following? Okay. Okay, thank you. Withdraw function. Okay, thank you very much. Should be called only by the contract owner. Okay, whichever you like is your contract, is your logic. Probably a mapping of address to phone. Exactly. So yeah. So now we want to have a function to donate to a project. Donate of fund project. Let's use fund project. External. So we have we haven't set the state for users that are coming to vote. I say vote. That are coming to fund a project. Now we need to create a struct. Struct. What should we name it? Donor. Donors. Donors list. Let's use donors list. So we want to have the address of the donor, and then we want to have UN 256 amount contributed. So another thing that we need to have, just like I don't know who said that, we need a mapping to map address of a particular user to their struct. So map address to donors list. So can name it donors list. So what else do we need? What else do we need? We also need, we might need to get all donors for that particular project. So what we do here is we call this struct donors list an array, and then all donors information. So we can query that later to get all donors information, all their addresses, and the amount each user contributed. So now we have this fund project. So when you want to fund a project, since we are making use of Ether in this project, so we need to make this function payable since we are making use of Ether. So the first thing that you want to check is that we require that, hey, please, excuse me. Okay, I'm sorry for that breaking transmission. So we want to first require that the the amount this person is passing in is not zero. So we need to ensure that check that msg.value is greater than zero, else throw this error. Zero ETH not allowed. How do you want to waste your gas? So that's the first thing that we want to check, right? So the second thing that we want to check is, so what should we check? What should we check? We should also check before someone wants to fund a project, we should also check that the duration that was set for that particular project has not exceeded, it has not elapsed. So let's check. So I think that's the first thing that we should check for. Yeah, that should be the first thing that we should check for. That require that block the timestamp, which is the current block the timestamp that this person that wants to fund the project is coming, is less than or equal to project duration. Else, we should throw an error that project um, project time exceeded or project duration exceeded, anyone. Project duration exceeded. So that's an important check. So now, what else do you think we should check for? What else do you think we should check for? Are we good? Are we good? Please, if you want to speak, you can just like unmute your mic and speak, because we're running out of time already. We're running out of time already. So I think those are the basic ones that we need to. So now, let's now point to this struct so that the person can make their donations, and then we can record their donations on the smart contract. So we call this donors list storage. That's, we're pointing to the storage. So let's use this equals to, now what's the name of the mapping? We have underscore donor list. What's the key? The key is address. So we're going to be using msg.sender. So now we want to access that particular struct for that particular msg.sender. For that person that wants to fund that project, we want to access the struct so that we can store their value in the state, and also so that they can successfully make their donation. So list dot donor first equals to msg.sender. Second thing, list dot amount contributed equals to list dot amount contributed plus msg dot value. So the reason why I'm using this again is because, okay, let's say the user wants to come back to donate. Normally, you should just have this list dot amount contributed equals to msg dot value. So if it equals to msg dot value, that means if you come in now, the msg dot value that will be stored, let's say you're inputting 1 ether, the msg dot value that will be stored in your struct is 1 ether. And then if you come again to donate, maybe you come again to donate 2 ether, what will be stored is 2 ether. It will not add those two together, so it will just override. And if you now come back to now store maybe 0.5, what we store in the state is that you actually contributed 0.5. It will not add up everything, but to add up everything, so we need to do this now. So now we need an event. Should we create an event for this? Okay. Project funded. So we want to pass in an address indexed for that particular msg.sender caller. What else? We want to get the amount that they actually contributed, indexed amount made. So that's what we need right here. So what we just do now is to now emit that event. to emit that event right here. So before we emit the event, we need to push these two. We need to push the information into the array so that when we get this array, we can like query all donors information. So what we do right here is all donor information dot push. What you're pushing is lists. So it push the msg of sender, the address, and the value. So now you want to emit the event project funded. So caller is msg of sender, and then the amount made equals to list dot amount contributed. So this is set. So another function that we need, let me see if anybody has given me idea of what we can also put. A withdraw function, which should be called only by the contract owner, I think. Okay. So we should have a function. So what a function to transfer to beneficiary, to the beneficiary of that project. Transfer oh, it's gone. Wow. Hey, Jesus. So we need to set the address of the beneficiary right here. So since we already have one factory, we can state this as the new table. So address of project beneficiary. We need to also set it up in the project that this setup project that okay, oh, is this person that I want to undo then. Let me just use then. So project beneficiary equals to underscore ben. So right here, the first, when you want to transfer to beneficiary, you want to make sure that the person that is calling this contract, like who gave the suggestion? Like Favor said, you want to make sure that this person that wants to transfer to beneficiary is actually the admin of that particular project. So we need to require, no, first, before we require that is the admin that is calling the function, we need to, yes, let's require first that is the admin that is calling the function. We require that msg.sender equals to admin, project admin, else you are not admin or not admin, whichever one you want, not project admin. So that's the first check, that okay, anybody that wants to have access to this thing is only the project admin that you want to have access to this particular function, to be able to call this function. So the second check that I want to check that okay, even this project admin has access to this function already. Now we want to make sure that before this function can run successfully, we want to ensure that okay, the project the duration has actually exceeded before the admin can transfer to beneficiary. So you require that log.timestamp right now is greater than project duration, else project, what is happening, else project still running, or project still in progress, or contribution still in progress. Anyone? Let me use funding still in progress, so that you understand. Funding still in progress. So another thing that we want to check is that, okay, we want to check that to transfer to beneficiary, we want to check that, okay, oh, the target for this particular project has been met, right? So let's check that. Require that projects um we want to check that the target has been met. So we need to we need to have another I say another this thing to target reached, another state, target reached. We can use target reach for anyone. So first, sorry, before we make this check, we need to actually pass in the address of the beneficiary, address of Ben, that's called Ben. So right here, I said we need to check that, okay, and then the amount that you want to send, doing 256 amount. So we want to check that this amount is equal to the target, sorry, project target. So right here we don't need this book, but you can use it if you want. Right now you're already making comparison using the amount passed and the target. So require that the amount equals to project target. So you should throw an error that either incorrect amount or, okay, let me just use incorrect amount here and then use bool to check that target reached. So we want to also check, require that incorrect amount, require that target reached equals to true. Else throw this error, target not reached. Oh, so much require. Another thing that we need to check is that the address that this person is passing in, the admin is passing in, the admin can mistakenly pass the address that is not the admin's. I mean, that is not the beneficiaries. So we need to check that, require that underscore Ben is actually equals to project beneficiary, not project beneficiary. So now we can now start. I think, yeah, we have done all the checks that is necessary. So we can now start making writing to the state, right? So the first thing that we need to do is get the contract balance. Contract balance equals to, the way to get to contract balance, you use address this, that is all the ethers that have been donated into that particular smart contract dot balance. And there's this dot balance. Why are you not giving me option now? So okay, now since we're using address d dot balance, I actually don't need this state, this target reached again. So it will not just be like redundant code. So I need to make a check right here that require that um require that the contract balance is greater than or equal to the project target. So it should not even be equal to, greater than project. Well, it can be greater than, whichever, whichever you want. Project targets. Target not reached. Our time is fast spent. Please, who is there? Can I continue? I don't know if any of the admins are here. Let me just
Yes.
continue.
So yeah. So you just need to like wrap up. And another good thing we
Wow.
can help with this particular project, if you can help push it to give and share the link to everyone, then
Okay,
I think
sure, no problem.
that can also help. But I think, are
Okay.
you almost done?
I'll not lie to you, I'm not almost done.
Oh, okay.
I wanted them to
So
like
yeah,
understand
yeah.
this.
Additionally, what you can do is um, the remaining parts, just continue to like 7. Then the remaining parts, maybe you can just finish it off and add comment, then probably push the link and share the URL so that we can share with everyone.
Okay, okay, no
Yeah,
problem. Probably
thank
what
you.
I'll just do, okay, wherever I stop, I'll make a video and then share with you. I think that will be
Yeah,
better.
that works. Yeah, that works too. Thank you for having.
Okay, okay, let's just complete this crowdfund. We're almost done with the crowdfund itself. So, you can see the reason why I'm using payable, because we're going to be dealing with ether. Now we want to transfer the money to safest method ether is using .com. So I want to now transfer, since all of these all these checks that we have has already passed. Now let's now write to this bull success equals to, so we now call the address, this ben is the address of the beneficiary, dot call, you're using call, and then you pass in a parenthesis, and then the value column, then amount that you want to transfer. And you can either use amount or use contra balance. But one thing with using contra balance is, in a case whereby every the ether that was contributed in that particular smart contract, it exceeds the project target. So if you use adjusted or balance, that means that you're sending above that particular project target. So it should just be okay for you to pass it the amount instead of using adjusted or balance, and then the extra one that remain, you can transfer it to yourself or add it to another project. So that's that. So use this, yeah, this is the way to use, but this is the way to use call. Now I want to require that this transaction actually succeeds, requires success. Else, you should revert that transaction failed. Transaction failed. Transaction failed. So after this, now I want to set, okay, we should also have a value, right? That that keeps track that, okay, this admin has actually withdrawn for this project. So let's create this one, funds, project funds withdrawn. Or transferred, whichever one. So you come here and then set it that, okay, project funds withdrawn is now true, so that in a case whereby the admin wants to come back to make transfer again or something, you should throw error that, okay, let me even check it right now. Let me check it right now. I should check it that if require that pro require that not project withdrawn, you have not withdrawn you have not withdrawn transfer to the beneficiary, funds transferred. You cannot transfer twice, fund transfer, because we are adding that, okay, for different projects, right, we want to have different smart contracts. So once a particular funds have been, the target has been reached, that's the end of that one. You can deploy another one, but you can code it to the way you want it, right? So that, okay, you can reuse it. But what's the essence of the factory contract if you want to be reusing the templates or a duplicate? So that is that for transfer to beneficiary. Now let's get function to get all donors list, get all donors list. External view wants you to returns, what's the name of donors list. Okay, I think you should just give me the suggestion. Donors, okay, wants to return this array in memory. So just, what is happening here? Return, what's the name of this thing? Return all donor information. All donor information. So that's that. So if you want to also get the length, I mean, everybody, the length, I mean, how many people donated, get donor, get number, get donors length or number. You can use external view returns it's going to be returning you in 256 because it's the number, it's length that want to. So return, you want to return all donors dot length dot length. So that's that. So what other function do we need in this? So we already have function to set up, we have function to fund project, function to transfer to beneficiary. Okay, we need a function to refund. So in a case whereby the target was not reached, the target for that project was not reached, you want users to be able to get their money back. So function to refund. Function to refund. Now, we want to first require that block the timestamp is greater than project duration. Else, project still in progress. Another thing I want to check is that the person that is coming to claim this thing actually donated. So we need a mapping. We need to store a mapping that, okay, a mapping to check that a user donated for a cause. The key is address to Bo, returns Bo, donated, contributed, whichever. So we should store it inside this place, inside this fund project. Yeah, we should store it here. We should store it here. That's donated for Immersion.sender. We want to store it that is true. After this thing, everything has run successfully. Is true. So now, before the person, the caller wants to come and check, come and claim their money, want to check that this particular person that is coming to claim actually made contribution. So require that donated of Immersion.sender equals to true. Else, you're supposed to tell them that you are a thief. Go back. You didn't make contribution. Didn't make contribution. So another thing that we should check, we should check that project duration. Okay, we should check that the project target was not reached. So require that. But this is the first thing that should come. No. Okay, I think this is right. We want to check that the project duration is more than the block or timestamp. So the other thing that we should check is that the target was not reached. Now we need to get in 256 of contract balance equals to address this dot balance. So we want to require that project target was actually not reached. Project target is less than contract balance. So else show is that, okay, target was reached, you cannot claim. Why do you want to come back to claim when project has been target reached? So those are the checks that you need. I think everything. So we need to make this payable also, since we are dealing with ether. We need to make this payable. So now let's make the transfer. All success equals to Immersion.sender dot call value. Now, what we need that person, so we need to access, we actually need to access this person's struct. So we come here. What did we name this thing? Donors, is it okay? Donors list. Yeah, donors list. Donors list. To give me the suggestion. Donors list storage. So list equals to what did I name this thing? Oh, underscore donors list. You want to be able to access this particular image dot sender. We want to access the image dot sender's information. So passing the key, which is the image dot sender. So now we want to get the money. So let's store this. User contribution equals to list dot amount contributed. So what you now need to refund back to this user is the amount that they contributed. User contribution. So yeah, require that it went successfully, else transaction failed. Why the transaction failed? Either maybe that wasn't enough, or the money, there's no money in this contract, transaction failed. So yeah, we have everything that we need. We have everything that we need. Yes, we do have everything that we need. So at this point, do we have any question so I can answer? Do you have any question? Do you
No
have any
question.
question? Yeah, so you understand everything. So before I make my video, let me ask you question. So um what is the use of a factory contract? What is the use? Somebody should answer now. Was it not Victor that was talking? Is anybody there? What is the use of factory contract? Unmute your mic and speak, please.
Hello. I think factory contract is used to like how am I going to put it? Like it's used like as a template to generate or manage other contracts.
Okay, exactly. You got that right. Got that right. That's amazing. So is there any other question? Do you have any question whatsoever? Do you have any questions? I'm going to drop the link to the slides also, so that you can go, you can also go through the ways that you can create a factory contract. Though I will make sure I do the video so I can send it out. Okay, please go on, Victor. Ask your question.
Okay, I wanted to ask regarding the use of Haddad and EtherJS. I know that Haddad contains Ether library, like the packages and everything. So by using Haddad, you can just import the Ether's package. So I wanted to ask, since
Wait, I'm gonna hear you again. No,
don't have to use, right?
please can you come again? I didn't hear that.
I said since Haddad contains Ether's packages.
Yeah.
libraries and
No,
everything.
no,
So I wanted to ask if can you hear me, please?
I can hear you now, but you break like sometimes. Just continue, please.
Okay, yeah. So with that,
You sure, Luma? Can you hear me?
Are you still speaking, Victor?
okay, yeah. Sorry about the disruption. I was asking. I said that like during this project, how that was used. So I wanted to ask if ETA's library is still necessary to be used with Hadat, since Hadat already contains ETA's functions, the libraries and everything.
Of
That's using
course,
ETA's.
like it has yeah, is that already has it. So you're going to be using it. As you can see, when I was using this store contracts, like I was using it as to get contract factory, to get a lot of things that I need. If you want to get signer, everything you need it has to get all of that. So it has already been imported down for you already. You can see import it has from others. So you actually need it to be able to either deploy, interact, or test your script. So
Okay. So Hadat is more like it's an update of ETA's, something like that. Like on was built on top of ETA's, right?
it's a library that you need in your child. I don't know if you get, it's a library that actually you actually need to
Yeah.
make interaction or any other thing that you need to do in others. Like
Yeah. Yeah, sorry to quickly add to that. Hard hat on its own is just like think of it like a framework. For example, now if you want to spin up an application later, maybe a React application or a Next.js, you enter a command to spin it up, right? So same thing for hard hat. But what they did is that they pre-installed some few packages that will be useful for you. So instead of you doing it manually when you need them, it comes directly pre-installed on hard hat. So it's not as if it's like leveraging details that you mentioned, but it's a library. You know, details itself is a library, so it's already pre-installed in hard hat when you install them locally. That's why you have hard hat there, just like what Sarah mentioned. I hope you understand it, Victor.
Yes, I got it. And please, one more thing. I want to say, like he said, not all the packages in ETAs has been imported to Hadat. Let's say has been already built in Hadat. I wanted to ask if there will still be a need like to use Hadat and ETAs like somehow separately in the since like he said, not all ETAs packages not all that is how that does not have access to all ETA's packages. I don't know if that's what he said, if I got him. Hello, can you hear
no,
me?
you actually, I can hear you. Can you hear me? You actually need it as you need that library for any interaction that you're making. I mean, you need that library to be able to like make interaction for your contract on others. You need it. You need it as. So just know that you need it as. There's no way that you can use. I don't know how you're saying that use it separately. I don't know, but you need it as actually to be able to make interactions on your contract. So did you get that?
Okay, yeah. Thank you.
Okay, thank you very much. So is there any other question before we call it a day or a night? Okay. So I think the admin can take over now.